Chapter 6 sample test. Find the area enclosed by the curves f of x, g of x in the first quadrant. So let's look in the first quadrant. If I put in 0, can't. Put in 1, I get 4 minus 1 is 3. If I put in 2, I get 2 minus 1 is 1. I put in 3, 4/3 minus 1 is 1/3. Put in 4. 4 is 1 minus 1, which is 0. Okay, put in 1. That'd be 1/4. 1 minus 1/4 is 3/4. Put in 2. 0 over 1 minus 0 is 0. Oop, wait a minute. Put in 1. 1 minus 2 is negative 1. Squared is 1. 1 minus 1/4 is 3/4. Put in 2. 1 minus 0 is 1. Okay, not 0, 1. Put in 3, that's 1/4. 1 minus 1/4 is 3/4. And put in 2, I get 1 minus 1. Now put in 4, I get 1 minus 1, which is 0. If I put in 0, I get 1 minus 1, which is 0. Okay. In the first quadrant, these overlap, and that's the area between them. So they meet at 2 and at 4. I could have found that setting these equal to each other too to find out the 2 and 4. Let's do that. 4 over x minus 1 equal to 1 minus x minus 2 squared over 4. This might not be easy to do and may not be the way we want to do this. Let's see, if I minus 1, but those are not going to cancel. Excuse me. So let's see. Multiply everything by x, and we'd get 4 minus x equals x minus 2 squared times x over 4. So we have this is looking pretty messy. Probably not going to be the way we want to do this, but that would be, let's just get it all equal to 0. Actually, yeah, this one I wouldn't approach that way. I would just, could have put these into the calculator and asked for the intersection. Let's just do that so you can see that. Clear, this would be 4 divided by x minus 1. And the second graph would be 1 minus the quantity x minus 2 squared divided by 4. And if I push graph, there's the one of them, and there's the other one, and you can see they intersect at 2, 1, and 4, 0. And that's with my window and zoom 4. And I can check that by going second, calculate the intersection, enter That's one of the curves. Enter first curve. Enter what's not moving on. Oh, yes, enter. Oh, can't be on 0. It's got to be where it's non-zero. So that one, enter. This is the other curve, yes. And my guess is 2. And it says 2, 1. Yep. Then second, calculate the intersection. And that's one of my equations. That's the other one. And I've got to be, I think, out at 4 is my guess. And it says, yes, there's 0. So that's how I would find those on the calculator. Anyway, so I got to integrate. Now to find the area between the curves, I find the area under the low one subtracted from the area under the top one. So I find, and I can do it together. So the area under the low one, that's the first equation I did. And that's subtracted from the high one. So the second one is here. That's going to be 1 minus x minus 2 squared over 4. The top curve minus the area under the lower curve. And x is going to go from 2 to 4. Okay, so now let's see what we have here. So we get the integral from 2 to 4 of 1 minus x squared minus 4x plus 4 over 4, that's multiplying that out, minus 4 over x plus 1. And we got, so we have 2. Those are just 2 minus 4 over x plus 1/4 of x squared minus 4x plus 4. 1/4 of x squared is going to stick around. 1/4 of x squared is 1/4 x squared. 1/4 of minus 4x is going to be just minus x. 1/4 of 4 is 1. And 2 is plus 3. And then minus 4 over x dx. So the integral of the first one here would be 1/12 x to the third minus 1/2 x squared plus 3x minus 4 ln x. So from this, we're going to get, see, 4 times 4 is 16. Another 4 cancel, we'll have 16 thirds. 16 divided by 2 is minus 8 plus 12 minus 4 ln 4. All of this minus 8 divided by 12 would be 2/3. Two, that minus 2 plus 6 minus 4 ln 2. So we got 16 thirds minus 2 thirds is 14 thirds. Minus 8 plus 12 is 4. Minus a minus is plus 2 more, 6. Minus 6 is 0. See, this is plus 4. This is plus 4. 4 minus 4 is 0. And then we got minus 4 ln 4 minus 4 or plus 4 ln 2. There's some things we could do to simplify that, but let's just figure out what that is in decimal for the moment. So 14 divided by 3 minus 4 ln 4 plus 4 ln 2. I get 1.894. Let's hope, and that's approximately. Let's see if that matches. So look at back of the graph. Second, calculate 7, the area between the two curves. So I'm going to make a function for that. I'm going to go here, and the top one was y2. So vars, y variables, y2 minus y1 vars, y variables, function y1. And I can turn off the other ones. And so there's the graph of the difference. And the difference is a positive area between 2 and 4, and I want the area under that. So second, calculate 7, the area between 2, enter, and 4, enter, and it gives me 0.56. So somewhere I've made arithmetic error. Let's see here. How far back do I need to go? 1, see, that was minus and minus, so that's plus 1, 2. Then I got minus 4 over x minus, all these are minus. That should have been a minus there. So that should have been minus. That should have been plus. And so that's minus 4 plus 2. No, minus 1 plus 2 is 1. And then minus 4 over x. So I messed up my minus right there. Yep, same kind of stuff you guys do. So let's see here. Now I got to come down here. When I integrate that, that'll be a minus. Integrate that, it'll be plus. Integrate 1, that'll be just x. Integrate that, it'll be minus 4 ln x. So that's okay. Now, this would be minus 1/2 x squared. That would be, what was it before? Yeah, that should be plus. And this would be just x. And so this should not be 12, but should be 4. And minus ln 4. And then putting in 2, this should be minus. This should be 1/2 of 2 squared. That's still 1/2, but should be plus. And this one should not be 4, but should be just x, which is 2. And is that plus? Yes, plus 1. And minus that. Okay. So now I got minus 16 thirds minus a minus 2 thirds, which is plus 2 thirds. That's minus 14 thirds. 8 and 4 is 12. 2 and 2 is 4. So 12 minus 4 is 8. So I got plus 8. And then I've got minus 4, ln 4. Did I get the signs right on this one? I'm worried about that. Let's see here. If I put 2 in here, I got 2 squared 4, 1/2 of 4 is 2. If I put 4 in there, 16 by half, it's 8. Both of those are plus. And that is a plus x. Should that be plus x? Did I mess up again? Let's see. That was 2 minus 1 is 1, so that is plus x. Okay. So I have same thing I had, except I got to change the sign on the first one. And then I have minus 4 ln 4 plus 4 ln 2. Okay, my computer said I wasn't recording, but I guess I am still. Okay, and then I need a plus what else? What did I find here? Plus 8. Plus 8. There we go. So instead of that, I got the 0.5607. Okay. Arithmetic error. Easy to do. Okay, number 2. Hopefully they're not as messy on the test, but we'll see here. Find the volume of the solid by rotating the area in the first quadrant about the x-axis under y equals cosecant x. So let's see. Cosecant is the reciprocal of the sine. Sine goes like that. And we went from pi over 6. See, sine is pi over 6 would be here. This would be pi. And 2 pi over 3. So this area in the first quadrant about the x-axis. So it's going to go over and be down here. Oh, but this would be the sine curve. We want the cosecant, which goes like that. So now we've got all this shape. So it would be down here, something like that. Okay? So, since it's about the x-axis, we slice perpendicular to the x-axis, and that would come down and be down there. Get a circle. So the slice perpendicular to the x-axis would be dx integrated from pi over 6 to 2 pi over 3 of, so the thickness is this, it's a circle, so the area would be pi r squared, but r is the y value, which would be cosecant x squared. So the pi comes out, cosecant squared is integral of cosecant squared is negative cotangent x evaluated from pi over 6 to 2 pi over 3. Cotangent of 2 pi over 3. And remembering our trig, 2 pi over 3 is there. And at that location, the cosine is negative 1/2. The sine is square root of 3 over 2, and cotangent is not sine over cosine, but cosine over sine, so it'd be minus 1 over the square root of 3. And we have minus here. I'll take that minus out, so that actually make that plus. And then minus, now I'll put pi over 6, which is here. The sine is 1/2, and the cosine is square root of 3 over 2. So the cotangent is cosine over sine is square root of 3. So we have this minus would go and make both of these positive. And that would be our exact answer. Let's see what that is. Pi parenthesis 1 divided by the square root of 3 plus the square root of 3 enter 7.255. Now let's check. So I'm not telling you something wrong. The cosecant is 1 over the sine. 1 divided by sine x. Graph. There it is. Now I have to spin it around, and so it turns out to be what I want is not this one particular, but so I'm turning that one off. And I want to do the integral of pi cosecant, which is y1, vars, y variables function y1 squared, and that would look like, so here's the graph of the volume of these things, and I want to integrate this, second, calculate the integral from the lower limit of pi divided by 6 to the upper limit, which is 2 pi divided by 3. Oh, don't need a parenthesis. Enter. And it tells me it should be 7.255. So that one checks. And I checked that one. So far I'm doing okay, other than I had a minus sign I lost on that one. Number 3, the population of a city has a radial density, so as you go further out, it's a function of radius. The population probably decreases. And the way we do those is we take the radial density So that means the population per square whatever as we move out be times the area of a ring at that distance out. So we got to get the area of a ring, which have a width of dr and an area of dr times the length around, which is 2 pi r. That's the area times the density of that area, integrated from 0 to 5 kilometers out. So that would be, the 500 would come out and we get 1,000 pi, and this would be integral from 0 to 5. This is to the minus 1, so that would be in the denominator, 1 plus 0.16 r squared with an r in the numerator, dr. And it looks like the derivative of the denominator will produce an r, so I'm going to let u be the denominator, 1 plus 0.16 r squared du would equal 0.32 r dr, 2 times 0.16. Divide by that, and I get dr's replacement will be du over 0.32 r. So this becomes 1,000 pi, new limits. I could figure those out. 0 into here would be 1. 5 in there would be 25 times 0.16. 25 times 0.16 is 4 of, I have an r I haven't gotten rid of yet, and the d, and over u, and du, r is going to be replaced with du over 0.32 r. These r's do cancel. I can bring the 0.32 out, and I just have 1 over u, so it's going to be 1,000 pi over 0.32. Integral of 1 over u is ln u, evaluated from 1 to 4, or switch it back to ln of this and put in 0 and 5. But since I've already got these limits, that would be 1,000 pi over 0.32 ln 4 minus ln 1. And ln 1 is 0, so I just got that. So 1,000 pi divided by 0.32 times ln 4. Population within the first 5 kilometers on this city is 13609.9, so 13610. That's going to be approximate, of course. And let's see, is there a way to check that? We can go back to here, the setup, and do y equals 2 pi times 500 parenthesis 1 plus 0.16 x squared, close parenthesis, to the negative 1 times x, and graph, and probably won't see this, goes way up high. Doesn't really matter. I just want to integrate this. So I can calculate 7 between 0 and 5, and it tells me that the area is 15800. I messed up again. Where did I mess up? Make sure I got it typed in right. 2 pi r times 500 times 1.16x squared to the negative 1. Oh my goodness. Should be 1. What did I get? Second, calculate the area from 0 to 5. 15,800. Not doing so well here. All right. 2 pi times 500 is 1,000 pi, 0 to 1. R over, this is 1 over that squared. Let u be this. Derivative be 2 times that r. So that's there. So it becomes r and 0.32 r, and that is my u. And so I take the 0.32 to the outside, and the r's cancel, and the integral of, oh, and let's check my limits here. If I put 0 in here, 0.16 times 0 squared plus 1 is just 1. If I put in 5 squared is 25, and I think I did that. 0.16 times 25 is 4. Oh, 4 plus 1 is 5. There's my mistake. So this should have been 5. 5 and 1. So, whoop. So now let's go back and calculate this with a 5. There's the 15,800. I didn't do my limit change correctly. Doggone it. Okay. Moving right along here. Graph the area enclosed by the equations. X plus y equals 3. I'll just draw my axes there. X plus y equals 3 goes to 3, 0, 3, and 3, 0. Y equals x plus 1 goes through 1 with a slope of x. And y equals 1. Y equals 1 is here. The area enclosed by those 3 graphs is that. Set up an integral equation that would find the volume of the solid if the area was rotated about the x-axis. So if I took this about the x-axis, it would be, the image would come about down through here. Using the disk method. Disk means we have to slice it perpendicular to the axis. So perpendicular is that way, so I'd have to slice it this way. So to do that, it's going to be the difference between these two up to here, and then the difference between these two for the rest of it. And there is symmetry here. This half is going to equal that, so I could go with doing 2 pieces, or I can do 1 piece and double it. I'll do the first piece here. So that'd be the integral from 0 to 1. The thickness of this is dx. Get that down. dx. Integral from 0 to 1 of the upper curve, which is x plus 1. Okay, let's get this right here. Pi r of the larger one, the larger radius is up to there, which is, that's what this equation will give us, x plus 1 squared minus the smaller radius, which is just 1 squared. That would be, give me the volume of this. The area of the larger circle minus the area of the smaller circle times the thickness. The big circle minus the small circle. From here to here, and then I can either double this, which is what I'll do if I work this one out, but I could also do minus or plus the integral from, it would be pi. If I forget the 2, it would be the pi. Ooh, dang, not showing you this here. Okay, the larger radius is x plus 1. The smaller radius is just 1. And subtract those 2 radii times pi from 0 to 1. From 0 to 1. And for this part, it would be the larger radius, which would be 3 minus x minus the smaller radius on out here, and the slices out here would be just 1 squared dx. This, if I worked it out, should be the same value as this. So I'm not going to do that. I'm going to just double the first one. So I'm leaving that out if I were to find the volume doing this. Now, part C says use calculus method to solve one of them. Well, let's solve this one just so we have it. We're supposed to set it up, do the same thing with the shell method here, but let's work this one out. So 2 pi integral from 0 to 1 of x plus 1 squared, which would be x, I'm going to actually do the integral. X plus 1 squared would be x plus 1 to the third divided by the derivative inside, which is 1, so that's fine. And the integral of minus 1 is minus x evaluated from 0 to 1. So I get, put in 1, I get 2 cubed, which is 8, minus 1 times 2 pi, which is 7 times 2 is 14 pi for the volume. Hopefully I get 14 pi on the second part, or I've got an error. So now the shell method. I'm going to do B over here so you can see it. Hopefully I can keep this on the screen. I'm sorry about this. A lot of that was off the screen. I'll go back there and show you that. Okay, now the shell method means I have to slice it perpendicular or parallel to the axis of rotations, which would be something like this, which should have another one down here. And it would be a ring. The thickness would be in the y direction, so it's dy, doing the thickness, and it would be integrated from 1 to 2. That's where y is going to go from 1 to 2. And the ring would be the thickness times the distance around, which is 2 pi r but r is just how high it is, which is y. So r is y times the height. Well, that's the difference between this line and this line. This line that's the farthest out. That would be the x this way. It's x, the large x minus the small x. Large x from this line would be 3 minus y minus the small y, which would be solving for x in this would be y minus 1. Okay, so that would be 2 pi integral from 1 to 2. So this is a setup for b. And here's the working it out. So I have minus y, that's minus 2y. And I got 3 minus a minus 1, which would be 4. Distributing the y, I'd have 2 pi, and I have to distribute. I can't integrate that and integrate that separately because they're multiplied. 1 to 2 of minus 2y squared plus 4y. So that would give me 2 pi. That integrated be minus 2/3 y to the third plus 2y squared, evaluated from 1 to 2, which would be 16 minus 16/3 4 times 2 is 8 plus 8 minus 1 in there would be minus 2/3 plus 2. Okay, so we have minus 16/3 plus 2/3 is 14/3. Ooh, I don't like this because I'm supposed to come out with an even, and I'm coming up with a fraction here. So I've made a mistake somewhere. Dang. 2 pi, and then 8 minus 2 is 6. So that's goes in there 4 2/3 plus that's 10 2/3 times 2 pi, which is 21 1/3. They're supposed to be the same. Let's see if I can figure out what I did incorrectly. Let's go back to here. So I have to do the slice this way. So it's dy, and it would be, for slices, it's 2 pi r, and r will be up to there. That's y. Times, and the outside here, that would be the large x determined by this equation. So that would be 3 minus y minus this equation, which would be its x, which would be 1 y minus 1. So I got minus y minus 2y. 3 minus a minus 1 is 4 times y. Integrate this. It's going to be 3 divided by 3. Integrate that. 4y squared over 2, which is 2y squared. Put in 2. That's 8 times 2 is 16 over 3. 4 times 2 is 8. Minus Put 1 in there and I get minus 2/3 plus 2. So that's 16/3 minus 16/3 plus 2/3 is 14/3 minus 14/3. Yeah. Okay, that's not going to fix my problem, but minus 14/3 plus 8 and 2 is plus 8 minus 2 is 6. So that's off. So that's 4 2/3 minus from 6, that's 1 1/3. 2 pi times 1 1/3 or 4/3 is 8/3 or 2 2/3. Okay, let's check that answer on the calculator here. So y equals I have 2 pi x, and all these have to do an x, parenthesis 3 minus x, close parenthesis, minus parenthesis x minus 1, close parenthesis, graph. Second, calculate 7 between 1 and 2, and I get 8.377. 8.3775. Let's see if that matches up with 2.666666666 pi 8.3775. So that is the correct answer. What did I do wrong over here? Okay, so it was pi. So now we're doing this one. The large radius is y squared minus the inside radius, which is 1 squared. Thickness is dx from 0 to 1, from 0 to 1, and then this side is going to be match that one times 2. Okay. The integral of this should be x plus 1 to the third. Oh, man, why didn't you guys tell me while I was doing? Oh, over 3. Sorry, I forgot to put the over 3. So this should be 8/3 minus 1. So that is 2 2/3 minus 1, which is 1 2/3 times 2 is minus 1. Should be, when I double it, I should get 2 2/3 and not that. So 1 from 2 2/3. So let's see. If I put in 1, what am I missing here? 1 plus 1 is 2. Cubed is 8 over 3. I forgot the 3. Put in, then the integral of 1 is just x. And put in 0. Oh, there we go. There we go. Let's get rid of this. The 0 is not 0 here. So 2 pi x plus 1 to the third over 3 minus x from 0 to 1 And if I put in 1, I get 2 8/3 minus 1 minus, if I put in 0, I get 1/3 minus 0. There's what I needed. Okay, so this is 8/3 minus 1 and minus 1/3. This is 2 and 2/3 minus 1 is 1 and 2/3 minus 1/3 is 1 and 1/3 times 2 pi, which is 2 and 2/3 pi. Which is what I had over here. So easy to make little errors, like dividing by the 3 when I go so fast. I apologize, but I'm trying to catch all my mistakes here. Okay? Hopefully I can do one of these without making a mistake. Derive the formula for the volume of a hemisphere with radius r using calculus. Now we know the volume of a hemisphere is half of a sphere. That's 4/3 pi r cubed, so the hemisphere would be half of that, which is 2/3 pi r cubed. I'll set my axis there. And I think I'll do the disk method. You could do either. So I'm going to slice it perpendicular to the y-axis, which is that. So the thickness would be dy. I probably should do shelf too. Let's try the disk method first. So it would be the dy, and it would be pi r squared dy, that's the volume of that disk, integrated from 0 to r. Okay, but I need r in terms of this r in terms of y. And I'm going to draw this, which is the radius of the big circle, so I'm going to call that capital R. And this is y, so little r squared plus y squared is capital R squared. So little r squared is capital R squared minus y squared, integrated from 0 to, and so this should be capital R for our limits are, and pi dy, the capital R squared. Okay, so we have pi, capital R squared is a constant, so when I integrate it, it's R squared y, and minus y squared integrated would be y cubed over 3, evaluated from 0 to r, which would be put in the capital R, and we get pi capital R cubed minus capital R cubed over 3 minus, and putting 0 in for the y's here would be 0. And so r to the third minus a third of r to the third is 2r to the third times the pi over 3, which is the correct answer. Now, let's do it shell method. Okay, if I'm doing shell method, I slice parallel to the axis of rotation. So that would be something like out here. That would be in a circle. So I get this ring. The thickness of the ring, that thickness, would be dx. So I'd have dx, and I would be integrating x from 0 to capital R, and I would be doing 2 pi r, and r is x, and times the height, which would be y. 2 pi xy dx. But what is y? Well, in this particular picture, there is capital R, this is y, and this is x. So I would have, for y, I'd have y squared, y squared, my computer just says, forget me for a sec here. Hang on, I gotta type in my password. Okay, think it's still working. Yeah, it's still recording. Okay, so I got to figure out this. This is y squared plus x squared equals capital R squared. So I got to replace y with that would be capital R squared minus x squared square root. So it's 2 pi integral from 0 to r of x times the square root of capital R squared minus x squared dx. Okay, to integrate that, I would do a u substitution. So du would equal minus 2x dx. So I'm going to replace du dx with du over minus 2x. So I would now have 2 pi something to something of x, x, and then this would be the square root of u, and du would be, dx would be du over minus 2x. The x's would cancel, and I would have the minus 2 would come out here and make this minus pi. The 2's would cancel, but the minus would not. Integral from something to something of square root of u du, and the square root of u would be u to the 1/2. I'd have to raise that by 1, so that's 3/2 and times 2/3, so I'd have minus pi u to the 3/2 times 2/3, evaluated from who knows to who knows. Switching back would be minus pi 2/3. U was capital R squared minus x squared, and that would be to the 3/2, evaluated from back to 0 to capital R. So we would get minus 2 pi over 3 times capital R put in here would be capital R squared minus capital R squared, which would be 0, minus, putting in 0, I'd get capital R squared to the 3 halves. The square root of R squared is capital R cubed, so I'd get R cubed. So what do I get out of it? Minus and the minus cancel, and I get 2 pi over 3 plus R cubed. Okay. Got the same thing for both of them. I finally did something right. Okay. Number 6. A person standing on the roof of a building that is 5 meters high and is lifting a bucket 20 kilograms tied to a rope. This person's up here trying not to fall off and pulling this up. The rope is 0.05 kilograms per meter. And the bucket's on the ground. And they're trying to lift it up there. So we're going to lift it up 5 meters. So, again, 2 ways to approach this one. Let's start with, let's see, it's MAD, the mass. Now that's going to be 0.05 kilograms per meter times however many meters is out here of this. So that would, let's call this X or Y, whichever, times X. That's how much is out there. And that's going to change, plus the 20 kilograms that's always going to be there. The X is in meters, side canceled, so that'd be kilograms times kilograms. That's the mass. Density times length plus the other mass. The acceleration due to gravity times the distance I'm going to lift it, which is going to be dx, and then I'll lift it a little bit, then the mass will change, lift it a little bit, the mass will change, and keep changing, and add up all those little changes from 0, x is going to go from 0 to 5, or 5 to 0, whichever way. But we want the positive answer, so I'm just going to 0 to 5. So that would be 0.05x plus 20 times 9.8 dx, which is going to be 9.8 0.025 x squared, divide that by 2, plus 20x evaluated from 0 to 5, which will be, that one's not so easy. That's going to be 0.0625, something like that. Let's see, 5 squared is 25 times 0.025 plus, well, let's just figure that out, make sure I get that. Yep, 0.625 plus 20 times 5 is 100 times 9.8. So plus 100. And if I put in 0, I get nothing. So that times 9.8, 986 and an eighth joules. Okay, now the other way to think about this is lifting the 20 kilograms, which should be 20 mass times acceleration times the distance, and that will go the full 5. So that's lifting the bucket, plus, and we don't have to do that in pieces, then we got to lift the chain. And so we'll take a small chunk of the chain, which will be dx length, times its linear density, which is 0.05, times acceleration due to gravity. So the small mass times that's short, the density times a short length times 9.8 gravity, lifting it x, and integrating that from 0 to 5. And the x is the distance. Acceleration, that's the a, x is the d, that's, and the mass is 0.05 times dx. M, a, and d. And if you look at that, we integrate, we got the 9.8, 0.05 integrate times x integrated would be that. And then we have the 25x there. So this will come out to be the same 986 and 1/8 joules. All the same pieces, just a different way of looking at it. Okay? So I'm doing pretty well on this page. I got both of them to work without making a mistake. Okay, see if I can have the same luck on this one. Determine the work pumping the water out of the top of this full conical tank with the base diameter of 6, which means the radius is 3. Meters, and the height of 9 meters. So we're going to slice it, and we're going to slice it this way because we've got to lift that slice. And from class, I get the feeling that you'll probably want to call this dy. I probably should have done the last one with dy, but I did dx. So dy, and so we have to do mass is going to be the density, and this is of water, so that's 1,000 kilograms per meter cubed. Times volume, which is going to be dy times pi r squared. So density times volume is the mass times acceleration due to gravity times the distance I'm lifting it. So if I'm putting the axis down here, this would be 9. This would be the y. And so this would be 9 minus y. So there's the distance I'm lifting it. This is the A, and the volume times the density. And I'm going to integrate this from y being 0 to 9. Okay. So cleaning this up a little bit, I've got 9.8 times that's 9800, and the pi. On the outside, 0 to 9 of 9 minus y times r squared. So let's see, I need to solve for r. I'm seeing triangles. Boop, boop. This was 9 minus y. Then I've got this big triangle. So I want to solve for r. So I'm going to start with r. R is to 9 minus y as 3 is to 9. To solve for r, I just need to get this out of there, so I'm going to multiply by 9 minus y. And I get, and this is 1/3, so I get r equals 1/3 of 9 and 1/3 of minus y. And I've got to square that. So r squared would be 3 times, if I think about this squared, it's going to be 3 times 3 is 9. 3 times the third y is just y, and third times y is just y. So that's minus 2y plus 1/9 y squared. So I've got 9 minus 2y plus 1/9 y squared. And let's see here. You know what? I think this would have been easier another way here. Well, let me show you what I'm seeing. I could multiply the 9 times all this and the y times all this, but I've just realized there might be a little bit shorter here. I went too far here. I see a 9 minus y and a 9 minus y, and if I squared 1/3 times 9 minus y, I think that might be easier to look at here. So let's do this. 9800 pi 0 to 9. We got a 9 minus y times, this was 9 minus y times 1/3 squared. So the 1/3 squared is 1/9. 9 minus y squared. So I have 9 minus y squared times 1/3 dy. So I've got 9 minus y to the third 1/3 integrated from 0 to 9 dy. And that, I think, would be fairly easy to integrate. It would be 9 minus y to the 4th over 4, but the derivative inside would produce a negative, so I got to put a negative on this. Evaluated from 0 to 9. And so if I put 9 in here, I get 9 minus 9, which is 0 over 4, or to the 4th is 0 over 4, which is 0. So I'm going to get 0 minus, and then when I put in 0, I'm going to get the 9800 pi over 3 times 9 to the 4th over negative 4. And the negatives will cancel. And I'm going to get a final answer of, let's see, 9800 times 9 to the 4th divided by 12. So 5358150 pi joules, or working it out, times pi is 168.33124 joules. This would have been fine. This would have been fine. Okay. A lot of joules. Finally got it. And you notice I gave you these, and I will give you those on the test, just so you know how to integrate those in case you need them. Okay.